Good afternoon. Today I am going to start pair, ordered pair, then ordered pair, Cartesian product of two sets, Cartesian product of two sets and their graphical representation. Their graphical representation. Cartesian product of set of real number. Product of set of real numbers. R cross R and R cross R. So, first of all, I want to tell you about the pairs. What concept in your mind, what is the difference between pair and ordered pair? I am writing some pairs, for example of some pairs like husband and wife. This is a pair. Mother and son. I am writing these are pairs. Teacher and students. I have written here pairs. Husband, wife. They are pair. Mother and son. Teachers and students. They are treated as pair. You have seen in coordinate geometry, you studied the coordinate geometry, when you plot the point 2, 3, this is 1, 2, this is 1, 2, 3. When you plot the point 2, 3, this point is P, 2, 3. So, this 2, 3 is pair of, this is a pair, but this pair is written in specific order. What is the specific order in this? First of all, you have written the measurement of this point along x-axis, that is 2. Then the measurement of this point along y-axis, that is 3. And you have written this pair in a specific order. That's why this is a pair as well as the ordered pair. So now we reach to the definition of ordered pair. Ordered pair. Ordered pair is written by listing two objects in a specific order. For example, another definition. For A belongs to A and B belongs to B, AB belongs to Cartesian product A cross B. Here A and B are written in a specific manner. This pair becomes ordered pair because of, in this pair your first element A is a member of A and second element B is a member of B. Then this pair AB is written in a specific order and that belongs to the A cross B. That is the Cartesian product of two sets A and B. So now how can we define A cross B? I have given you the pair and then ordered pair. In ordered pair we are writing two objects in a specific order. So in this way your Cartesian product of two sets, Cartesian product of two non-empty set A and B is denoted by A cross B and defined by A cross B is equals to an ordered pair AB such that your first element A is member of A and B belongs to B. So can you say your AB and BA, what you can say about AB and BA? AB and BA are not equals. Now when you say two ordered pairs are equal, two ordered pair AB equals to CD, this is only when A equal to C and B equal to D. When their corresponding elements are equal, if the ordered pair of corresponding element means their first element are equal and their second element are equal, then we say that our ordered pair, this is equal. If A is equal to C and B equal to D, then you say that these ordered pairs are equal. Now I am taking one example. You find A cross B. How we find A cross B for the set A equals to set AB and B is the set XY, and A cross B can be written as AX, second element is AY, and BX, third element, and BY is fourth element. Sometimes we have to obtain the sets when the Cartesian product is given. When you find B cross A, then what is the change? In B cross A, in A cross B, you have obtained AB cross XY, and in B cross A, this is XY cross AB, and this Cartesian product is written as XA, XB, YA, YB. So when you find A cross B and B cross A cross B is not equal to B cross A. A cross B and B cross A are not equal. Now here number of element in A is 2, number of element in B is also 2. So number of element in A cross B is equal to number of element in A into number of element in B, that is 4. Now number of element in A cross B cross C is equal to number of element in A into number of element in B number of element in C. So this becomes the formula. So if a set A contains A element, one element, if number of element in A equals to M, number of element in B equals to N, then number of element in A cross B is equals to Mn, their product. You have seen that. So I have shown you Cartesian of product. Now you see question. Find the value of A and B. Now I reach to question. You do one question. Find the value of A and B, that is the question. Find the value of A and B if first A minus 3, B plus 7 is equal to 2 minus 5, and second 2A minus 5, 4 is equals to 9, B plus 4. So you see that you have given that these two ordered pairs are equal. When two ordered pairs are equal, then their corresponding elements are equals. Apply the definition of equal ordered pairs and you have the value of A and B. By using the definition of equal ordered pairs. Use this A minus 3 is equal to 2. This implies that A is 5. B plus 7 is equal to minus 5. B is equals to minus 12. So A is 5 and B is minus 12. In second part, again 2A minus 5 is equal to 9. 2A is equal to 14. A is equals to 7. And B plus 4 is equal to 4, B is 0. So value of A is 7 and B is 0. Another question? Question 2. Question: if x upon 3 plus 1, y minus 2 by 3 is equal to 5 by 3, 1 by 3, find the value of x and y. That is the question. Find the value of x and y. Use the concept of equal ordered pairs. When you say that two ordered pairs are equal, apply that. Your x by 3 plus 1 equal to 5 by 3. X by 3 is equal to 5 by 3 minus 1. X by 3 equal to 2 by 3. Your value of x is 2. Similarly, y minus 2 by 3 equal to 1 by 3. Y is 2 upon 3 plus 1 upon 3. When you solve them, it is 1. So your value of x is 2 and y is 1. Now graphical representation and Cartesian product of two sets. Cartesian product and their graphical representation. Cartesian product of two non-empty set and their graphical representation. Graphical representation. Now in this we take example. Question: if A equal to 2, 4, 6 and B equal to 1, 4, show that A cross B is not equal to B cross A. Also show A cross B graphically. That is the question. Also show this graphically. How will you show this graphically? First you find A cross B. Now solution. A cross B is equals to set 2, 4, 6 cross 1, 4. You write the element of A cross B. That is equals to 2, 1, 2, 4. 4, 1, 4, 4. 6, 1, 6, 4. This is your A cross B. Now you find B cross A. That is equals to 1, 4 cross 2, 4, 6. Your B cross A is equals to 1, 2, 1, 4, 1, 6. 4, 2, 4, 4, 4, 6. When you observe 1 and 2, this is 1, this is 2. By making observation, in 1 and 2, we can say that A cross B is not equal to B cross A. A cross B and B cross A are not equal. Next, their graphical representation. How can we show? Graphically. First of all, we draw, in order to show it graphically, we draw two mutually perpendicular lines and mark horizontal line as x-axis and vertical line as y-axis. This is x, O, x dash, y, O, y dash. These are two mutually perpendicular lines. Horizontal line is taken as x-axis and vertical line as y-axis, and mark numbers on them. 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, and 6. Draw three perpendicular lines on x-axis at the point 2, 4 and 6. Three perpendicular lines through 2, through 4 and through 6. And similarly because there are two elements in set B, so through 1 and 4 you draw two perpendicular lines to y-axis. So this. So now you mark the point. What are the coordinates of the point? What are the position of the points where these perpendicular lines intersect? First point is A. This is 2, 1. And this point is 4, 1. This is B. And this point is C. 6, 1. This point is 2, 4. D. And this point is E. This is 4, 4. And this point is F. That is 6, 4. So you may see that these are the elements of A cross B. They have shown graphically here in two-dimensional system, and all the elements of A cross B are taken in a specific order. They can be said to be an ordered pair because the element of Cartesian product of two sets are taken in ordered pair. So I have given you the definition of that. You may notice this thing. Now, note. You write a note about this thing. There is some note, and these are the important notes. Number 1. A cross B is null set if and only if A equals to null set or B equals to null set. A cross B is null set only when one of the set has no element. One set must be empty for that. Second, A cross B is not equals to phi, means it is not an empty set if and only if A is not phi. Both, it is necessary that both are not empty. A is not equal to phi and B is not equal to phi. Both the sets have some element, then you say that A cross B has also some element. If A cross B is not equal to phi, if A cross B is not empty, then this implies that A and B both are not empty. Now third point. Number of element in A cross B is taken as number of element in A multiplied by number of element in B. Once again I am repeating the whole note. Note 1. A cross B is null set if and only if A is null set or B is null set. A cross B is not an empty set if and only if both the sets A and B are not empty. And number of element in A cross B is equals to number of element in A multiplied by number of element in B. Now taking question. Question: if your set A cross B is given as AX, AY, BX, BY, then find set A and B. Find set A and B. So now you see your Cartesian solution. Cartesian product of A and B is the Cartesian product of two sets. One set is containing element AB. This is obtained by collecting the first element of each ordered pair. And by keeping this thing in my mind that the elements are not repeated while writing the element of the set. So this is the Cartesian product of two sets. One is the set A, which is obtained by collecting the first element of this set. AB cross XY. So when you compare both the sides, so you obtain the set A and B. By comparing both the sides, your set A is by comparing. Your rule is comparison. By comparing, we get set A equals to AB and set B equals to XY. There are two sets A and B. Now order triplet. Now you see about order triplet. Order triplet. In this, if A is a member of A, B belongs to B, C belongs to C, then Cartesian product of A, B and C, A cross B cross C, is defined as an triplet. Triples we can say triples also. ABC such that A belongs to A, B belongs to B, and C will not, there is no and. C belongs to C. So this is the ordered triplets. Now question. Now I am taking question. Question: if set A is equal to minus 1 1, then find A cross A cross A. First of all, you find solution. Find A cross A for the given set. You write the same set 3 times. That is for your convenience. Minus 1 1. A is again the same set. And third is A minus 1 1. You find A cross A between these two sets. You find the Cartesian product. So that is equals to minus 1 1 cross minus 1 1. Do it carefully. A cross A consists of element minus 1 minus 1, minus 1 1, and 1 minus 1 1 1. Again you find A cross A. So it is minus 1 1 cross, you write A cross A. So it is minus 1 minus 1, minus 1 1, 1 minus 1, and 1 1. So that is equals to, first you correlate minus 1 with each pair. Like this, you go like that. So it is minus 1, minus 1, minus 1. Then minus 1, minus 1, 1. Then minus 1, 1, minus 1. Then minus 1, 1, 1. Again, you correlate with this. It is 1, minus 1, minus 1. Next one is 1, minus 1, 1. And again 1 1 minus 1, and last one is 1 1 1. So in this way you find A cross A cross A. This is the point in two-dimensional plane. This is A cross A denotes the point in two-dimensional plane. What do you conclude from this? A cross A, conclusion. A cross A denotes the point in two-dimensional plane. Two-dimensional plane. And A cross A denotes the point in three-dimensional space. Three-dimensional space. You remember this point, and this is very important because sometimes question related to that is asked in competitive exam. Now again question. Question. Is set A question. If set A equal to element 2 3 and set B is equals to 3 4 5, then find number of element in A cross B, that is n of A cross B. So here solution. Here number of element in A, you count how many elements are there? 2. Number of element in B is 3. So by formula formula, number of element in A cross B is equal to number of element in A multiplied by number of element in B. So this is equal to 2 multiplied by 3, it is 6. You can do in this way. Another question. If set A equal to 4, 5, 6 and set B equals to 4, 5, 8, 9, then find number of element in A cross A intersection B. This is an important question. So first in support of that, we find first A cross A intersection B. How many elements are there? A is 4, 5, 6. Intersection B is 4, 5, 8, 9. A intersection B have the element 4, 5. Number of element in A intersection B is equal to 2. Now number of element in A cross A intersection B, this is equal to number of element in A multiplied by number of element in A intersection B. Now number of element in A is 3 and number of element in A intersection B is 2. So by using this you can write this is 3 multiplied by 2, it is 6. How many elements are there? There is 6 elements. Now another question. Your question is given like this. If A cross B is defined as A1, A5 and A2, B2, B5 and B1, then find, your question is find sets A, B and B cross A. A cross B is already given, so with the help of that you can find the set A and B, then you can find B cross A. Now solution, how can you write the solution? You must see that. Your A cross B is given as A1, A5, A2, B2, B5 and B1. Your in this Cartesian product, your first set is A. So then set A is obtained by collecting the first element of the each ordered pair. So in this way, A cross B is defined as the Cartesian product of A, B cross, and set B is obtained by collecting the second element of each ordered pair. That is 1, 2, 5. So by comparison you can write your set A and set B. Your set A is by comparison set A is AB and set B is 1 to 5. Now your third question in this question is find B cross A. You find B cross A. First you write set B 1 to 5, then cross AB, and that is equals to, it is 1A, 1B, that is 2A, 2B, 5A, 5B. So this. Now another question. Let set A equal to 1, 2, set B is 1, 2, 3, 4, set C 5, 6, and D is equals to 5, 6, 7, 8. Verify that. First, A cross B intersection C equal to A cross B intersection A cross C. Second, A cross C is a subset of B cross D. There are two questions in this. So first of all, you find B intersection C. B intersection C is B is 1, 2, 3, 4, intersection 5, 6. That is equal to null set. They have no common element. Now your LHS is equal to A cross B intersection C. That is equal to A cross null set. When you find the Cartesian product of empty set with any other non-empty set, so that is equal to empty. A cross phi is phi, because in the Cartesian product if one of the set is null set, then the whole product will be null set. So LHS is phi. Now for RHS you find A cross B. Your A is 1, 2 and cross B is 1, 2, 3, 4. So you write all the element of A cross B, that is equal to 1, 1, 1, 2, 1, 3 and 1, 4, 2, 1, 2, 2, 2, 3, 2, 4. This is A cross B. Now you find A cross C. A cross C is defined as 1, 2 cross C is 5, 6. Your A cross C, this is 1. A cross C is defined as 1, 5, 1, 6 and 2, 5, 2, 6. This is 2. From 1 and 2, from 1 and 2, from 1 and 2, A cross B intersection A cross C, also they have no common element, that is 5, and this is RHS. Your RHS is also this, so LHS equal to RHS, hence it is verified. Therefore your result is verified. Now your A cross C is written in result number 2. Second part, you need to find out B cross D only. You find B cross D. In second part, you find B cross D because A cross C is already there. B cross D equals to B is 1, 2, 3, 4 cross D is 5, 6, 7, 8 and your elements are 1, 5, 1, 6, 1, 7, 1, 8. 2, 5, 2, 6, 2, 7, 2, 8. Now 3 5, 3 6, 3 7 and 3 8, 4 5, 4 6, 4 7 and 4 8. Now you see that 1 5 belongs to A cross C and 1 5 also belongs to B cross D. 1 6 belongs to A cross C and 1 6 also belongs to B cross D. 2 5 belongs to A cross C, 2 5 is element of B cross D. And 2 6 and 2 6 is also there. So every element of A cross C is a member of B cross D. Therefore, by the definition of subsets, your A cross C is a subset of B cross D. That is your second result. This is your second result of this question. You notice that. Now, another question. Another question. Another question. If set A is equal to 1 4, if set A equal to 1 4, B equal to 2 3 6, C equal to 2 3 7, then verify that. Then verify that 1 A cross B union C equals to A cross B union A cross C. Second, A cross B intersection C is equal to A cross B intersection A cross C. Third, A cross B minus C is equals to A cross B minus A cross C. You have to verify these three results. Now see its solution. First you find B union C. That is equals to 2 3 6 union 2 3 7. That is, your B union C is 2 3 6 7. Now A cross B union C, this is your LHS, that is equals to set A is 1 4 cross B union C is 2 3 6 7. That is equals to 1 2 1 3 1 6 1 7 4 2 4 3 4 6 and 4 7. This is your LHS. LHS is this much. Now RHS. In RHS you find A cross B. First you find A cross B. Your A cross B is 1 4 cross 2 3 6. That is equals to 1 2 1 3 1 6 4 2 4 3 and 4 6. This is your A cross B. Now A cross C. Your A is 1 4 cross C is 2 3 7. That is equals to 1 2 1 3 1 7, 4 2, 4 3 and 4 7. Now you find their union. Your RHS is the union of this. Your RHS is union of this. RHS equals to A cross B union A cross C. So A cross B and A cross C is there. When you write their union, you will get as LHS. Their union is 1 2 1 3 1 2 1 3 1 6 1 7 1 6 1 7 4 2 4 3 4 2 4 3 4 6 4 7. Four two, 4 3, 4 6 and 4 7. So that is the RHS. Now you can see your LHS 1 2 1 compare one by one. 1 2 1 3 1 6 and 1 7. 4 2 4 3 4 6 and 4 7. So if this is 1 and this is 2, from 1 and 2 we have the first result. Similarly, you can do the remaining part of this question. Now, in this way, today I will give you some idea about the relations, and tomorrow I will discuss it in detail. Now you see, initially in the starting of today's lecture, I have written pair and ordered pair. In order to show the relationship, you need a specific order, and that specific order are said to be ordered pairs. And for the relationship, if you are talking about human beings, so husband and wife, they have the relationship and they have the specific relationship, so that's why that can be treated as the ordered pair, and it can also taken as the relation between two sets. So now you see that a relation R. Now I am defining relation. A relation R from set A to set B. Both the set A and B are non-empty. So use the word non-empty set. A relation R from non-empty set A to non-empty set B. Non-empty set A to a non-empty set B. A relation R from non-empty set A to a non-empty set B is a subset of their Cartesian product. Now you see relationship, when you are writing the element of Cartesian product, they are in ordered pair and they are having specific relationship. Means a first element of each ordered pair is related to second element of that ordered pair. If this kind of the things are there, then we say that if R is subset of A cross B, then we say that R is a relation from set A to set. That's all for today. Thank you.